everyone, we are from BSED Math Grade 8. So for today's video, we are going to have a video tutorial about geometric series as our terminal output in Calculus 3.
So to start, let us first know what is geometric series. Geometric series is a sum of the geometric sequence where the ratio between successive terms is constant.
So for an example, we have 1 plus 2 plus 4 plus 8 plus 16 and so on and so forth or to infinity. So in this case, this is an example of geometric series because it is the summation of the geometric sequence and has a common ratio of 2. So this is the summation notation of the geometric series. The summation of a times r raised to n as n approaches from 0 to infinity, which is equals to a plus a times r plus a times r raised to 2 plus so on and so forth as a times r raised to n, where our a here would be the coefficient of each term, and our r would be the common ratio, and also our n would be the number of terms. So to better understand the summation notation, so say for example, we have a summation of 2 times 1/2 raised to n as n approaches from 0 to infinity. So in this example, our a, or the value of our a, would be 2, and the value of our r is 1/2. So as first stated on the summation notation written above, that the first term would be only the value of our a. So in this example, the value of our a is 2, so that is our first term. And for our second term, as stated above, it would be a times r. So we would multiply our value of our a and our r. So in this example, we have to multiply 2 times 1/2. So the answer would be 1. So that is our second term. Next term is we have to multiply the a times the r raised to 2. So it's given here in our example, we have to multiply 2 times 1/2 raised to 2, so the answer is 1/2, and so on and so forth. So therefore, our geometric series is 2 plus 1 plus 1/2 plus 1/4 plus to infinity. So that is the geometric series.
And also, in dealing with geometric series problems, let's always remember these things. Number 1 is that if our absolute value of our r, or our ratio, is greater than or equal to 1, therefore our series diverges. Number 2 is that if our absolute value of our r is less than 1, therefore our series converges. And if it converges, we will use the formula a over 1 minus r in order to determine where this series converges. And number 3, in finding the nth partial sum of the geometric series, we will have to use this formula. S sub n is equals to quantity a minus r raised to n plus 1 all over 1 minus r.
For example, given a series of 1/2 plus 3/4 plus 9, 8, plus 27 over 16 plus infinity. Kaya ang first ato na buhatan is pangitawon na to ang a sub 1 o ang ilang common ratio. So ang atong a sub 1, a is equal to 1/2. Sa pagpangita sa common ratio, since geometric series man i-divide na to ang a sub 2 which is 3/4 sa a sub 1 which is 1/2. So 3/4 divided by 1/2 is equal to 3/2. Okay, 3/2. Kaya ang next step na itong buhaton is pangitaon na itong absolute value sa common ratio. Kaya ang atong common ratio r is greater than or equal to 1. Ang ato ang r is 3/2. 3/2. Okay, ang absolute value sa 3/2 is equal to 3/2. Okay. 3/2 is greater than or equal to 1 is Since mas dako man ng 3/2 sa 1, mo siya ang divergence na siya.
So say for example, we have here the geometric series of 1/3 plus 1 over 9 plus 1 over 27 plus 1 over 81, so on and so forth. So the first thing we do is to find our first term or our A. So our A here is 1/3. Next here is to find the value of our R or our ratio. So as you can see, we cannot just easily identify in these numbers what is our ratio. So we have to simply, in order to find the ratio, we could simply divide the succeeding term to its previous term. So say for example, we have to divide 1 over 27 to 1 over 9, and the answer would be 3. Same with 1 over 9, divide 1 over 3 would also be 1/3. So therefore, our ratio here is 1/3. Since we already got our A, the value of our A, and also with the value of our R, we could also put this into summation form. So we could have summation of 1 over 3, which is our A, times 1 over 3, which is our ratio, raised to n. And as n approaches from 0 to infinity. So this is the summation form of our geometric series. Since we already got the value of our R, which is 1/3, now let us prove if our R, absolute value of our R, is less than 1. So in this case, we have to plug in the value of our R. So this would be absolute value of 1/3 less than 1. Simplify, the absolute value of our 1/3 is 1/3, and 1/3 is less than 1. So since 1/3 is less than 1, therefore this series converges. And since it converges, we will use the formula A over 1 minus R in order to determine where this series converges. So in this case, we have to plug in the value of our A, which is 1/3, and then all over 1 minus R, which is also 1/3, and simplify, this would be 1/3, all over 1 minus 1/3 would be 2/3, and then 1/3 all over 2/3 would be 1/2. So therefore, in this series, it converges to 1/2.
Summation of 5 over 4 raised to the power of n when n approaches to infinity. So, pareha ra gihapon, pangitaw na to ang A and R. Ang atong A is 5 over 4 raised to the power of 0 is equal to 0. And our R is 5 over 4. Then, apply the condition, absolute value of R greater than or equal to 1. Then, substitute absolute value of 5 over 4 greater than or equal to 1. And then absolute value of 5 over 4 is equal to 5 over 4 and greater than or equal to 1. Therefore, this geometric series is divergent.
For example, summation of n equals to 1 approaches to infinity of 4 over 5 to the power of n minus 1. So first step, we need to find our first term. A sub 1 is equals to 4 over 5. So in our n, we plug in 1 minus 1 is equals to 4 over 5 to the power of 0. Since our atong law of exponent, pag nata exponent na 0, it is equals to 1. So, our A sub 1 is equals to 1. So in our next step, we need to find our ratio, which is 4 over 5. So we need to substitute our R in this condition. The absolute value of 4 over 5. So therefore, 4 over 5 is less than to 1. It converges. Since it converges, we will use this formula A over 1 minus R
So our A is 1 over 1 minus our ratio, 4 over 5. 1 over 1 minus 4 over 5 is equals to 1 over 1 minus 4 over 5 is 1 over 5 is equals to 5. So it converges to 5.
So now, let's move on in finding the partial sum. So for example, this series. Summation of two quantity 4 over 5 raised to the power of n as n approaches to infinity. So we will use this formula, but before we will substitute, we will find first what is A and what is our R. So our A here is 2 and our R is equal to 4 over 5. Now let's use this formula. S sub n is equal to A minus R to the power of n plus 1 over 1 minus R. So we will find the S sub 2. Like for example, S sub 2. So it is equal to, the value of A is equal to 2 minus the value of RR is equal to 4 over 5 raised to the power of, since we use this 2, so we will substitute the n to 2 plus 1 over 1 minus the value of RR is equal to 4 over 5. So S sub 2 is equal to 2, let's find first this kaning naka-quantity. So 4 over 5 raised to the power of 2 plus 1 is equal to 3. So it is equal to 2 minus 64 over 125 over 1 minus 4 over 5. So let's find our S sub 2. So 2 minus 64 over 125 over 1 minus 4 over 5, it is equal to 7.44. So our S sub 2 is equal to 7.44. So next example, we will find the S sub 5. So S sub 5. But before that, let's first find what is our A and what is our R. So just like kanina, so our A is equal to 2 and our R is equal to 4 over 5. So, let's substitute it sa ato ang formula sa partial sum. So, our A is equal to 2 minus 4 over 5 raised to the power of, since 5 ang ato ang pangitaon, so 5 plus 1. All over 1 minus our R is equal to 4 over 5. So, S sub 5 is equal to 2 minus quantity 4 over 5 raised to the power of 5 plus 1 is equal to 6. So we have 2 minus 4,096 all over 15,625 all over 1 minus 4 over 5. So our S sub 5 is equal to 8.69.